Hello friends, welcome to my channel. In this video now I am going to explain about the Baeyer-Villiger oxidation. So Baeyer-Villiger oxidation, this is also one type of reagent chemistry as well as it comes under the named reaction. If you see in this reaction, actually two here Adolf von Baeyer and Victor Villiger, this two scientists are discovered this Baeyer-Villiger oxidation reaction. So simply acylic ketones are converted into esters, cyclic ketones are converted into lactones. వెరీ సింపుల్. అసైక్లిక్ కీటోన్స్ ఎక్కడైతే అక్కడ ఉంటాయో అక్కడ ఎస్టర్ని ఫామ్ చేయాల్సి ఉంటుంది. సైక్లిక్ కీటోన్స్ అనేటిని లాక్టోన్స్ని ఫామ్ చేయాల్సి ఉంటుంది. వెరీ సింపుల్. ఇన్సర్షన్ ఆఫ్ ఆక్సిజన్స్, జస్ట్ యూ కెన్ ఇన్సర్ట్ ద ఆక్సిజన్. సో హియర్ యూ కెన్ సీ ద మైగ్రేటరీ యాప్టిట్యూడ్. యాక్చువల్గా దిస్ ఈస్ ద Baeyer-Villiger ఆక్సిడేషన్స్కి హైడ్రోజన్ అనేది ఫస్ట్, హైడ్రోజన్ అనేది మోర్ ప్రయారిటీ, దెన్ టెర్షరీ, సెకండరీ, ఫినైల్, ప్రైమరీ అండ్ మిథైల్. దిస్ ఈస్ ద Baeyer-Villiger ఆక్సిడేషన్. ఎక్సెప్షన్ ఫర్ దిస్ Baeyer-Villiger ఆక్సిడేషన్స్కి మైగ్రేటరీ అనేది ఒకటి ఎక్సెప్షన్గా ఉంటుంది. యాక్చువల్గా అయితే జనరల్ ఆర్డర్ వచ్చేసి ఇది టెర్షరీ, సైక్లోహెక్సైల్స్ అండ్ సెకండరీ, ఫినైల్ అండ్ ప్రైమరీ, మిథైల్ అండ్ ద లాస్ట్ వన్ ఈస్ హైడ్రోజన్. దిస్ ఈస్ ఫర్ what జనరల్ మైగ్రేటరీ యాప్టిట్యూడ్. సో Baeyer-Villiger ఆక్సిడేషన్స్కి ఎక్సెప్షన్ ఇందులో హైడ్రోజన్ అనేది విల్ గివ్ ద మోర్ ప్రయారిటీ దెన్ టెర్షరీ, సెకండరీ, ఫినైల్, ప్రైమరీ అండ్ మిథైల్. This is for what Baeyer-Villiger oxidations of migratory group. If you see the reaction mechanism so that you can understand very easily what is that exactly happening in this Baeyer-Villiger oxidations, let's move to the reaction mechanism. So here I am going to take one ketone. So it is treated with the acid first. So here we oxygen containing a lone pair of electrons. This lone pair of electrons is subtract proton from here, then we can get here COH positive charge and R1. So it is treated with a peroxide group. So here I am going to take one peroxide group. This is the one peroxide group, right? So here we have a lone pair of electrons. This lone pair of electrons is migrated towards this carbonyl centers and this bond is migrated towards the oxygen. So we can see very careful, it is very simple reaction. So we can keep double bond. So here OH, here O, C double bond O, OR. Because here we have a hydrogen but unstable, if it is a hydrogen we can get positive charge, if it is unstable then I remove the hydrogen here itself. So if you see here we have a lone pair of electrons, right? So this lone pair of electrons is migrated here, this alkyl group is migrated this oxygen side. So see careful, this bond is migrated here, then we can get R1 O C double bond. This is the R1 O C double bond O R double one ester, and next byproduct will C double bond OH after workup. So we here get esters. This is the reaction mechanism. If you see the examples, here I am going to take ketones, cyclic ketones. So here I am use COOH or COOH peroxide group. So if you see in this reaction, here we have a tertiary, here we have a secondary, right? Which one tertiary is more priority than secondary? Then we can get just insertion of oxygen. ఈ మధ్యలో అనేది మనము ఆక్సిజన్ ఇన్సర్ట్ చేస్తే చాలు, అదే మన ఆన్సర్. సింపుల్. సో దిస్ ఈజ్ ఫర్ వాట్ అవర్ ప్రోడక్ట్, right? If you see one more example so that you can understand better, I will give one more example, more examples to you. So here you can see, here I am going to take one ketone. It is treated with MCPBA. Metachloroperbenzoic acid, MCPBA, is nothing but Baeyer-Villiger oxidation also you can call that. So here we have a here we have a secondary, here we have secondary, right? So anywhere you can introduce insertion of oxygen, nothing. So here I am going to introduce an oxygen. So this is for what? Our product. And if you see one more example, here we have a ketones, MCPBA. Obviously you can insert here itself, right? So write O ketone. So this is for what? Our product. And next, if you see the more examples, I will give the more examples to you. So here I given one example, CH3. It is treated with MCPBA, where you are going to introduce. See, here we have a CH3, here we have a benzene. So which one is more priority? Will give benzene is obviously will give the more priority, right? So you can insert the oxygen benzene side, not CH3 side. So this is for what? Our product. If you see one more example, here fluorine, here bromine, here C double bond O H, MCPBA. So where you are going to introduce, here we have a ketone, right? Here H, here benzene ring. So don't be confused while writing this answer. Most of the persons, so here we have a phenyls and benzene ring side. So we need to introduce the oxygen here itself, not here itself. Exception in Baeyer-Villiger oxidations. Hydrogen will give more priority, right? More priority. So obviously you can insert the oxygen from hydrogen side, not in benzene side. Please remember while writing this Baeyer-Villiger oxidation. C double bond OH and remaining you can keep as is. This is for what? Our product. If you see one more example, here we have a acyclic ketones, MCPPA. Just now I had a discussion with you, right? Acyclic ketones are going to converted into esters. Here we have a CH3, here we have a more number of groups, right? Obviously you can insert the oxygen here itself. This is for what? Our product. If you see one more example, if you practice more examples, it will more better for you. And MCPBA. So where you are going to introduce or insert an oxygen? Obviously here, right? So here you can keep as is. This is for what? Our product. If you see one more example, I will give the more example. So here we have a 5-membered ring. So it is treated with a 2 equivalents of H2O2 and MTO, and next it is 20.5 ml and ET2O and RT. MTO is nothing but methyl trioxoranium. This is also one type of peroxide formation. So here we can see here H2O2, right? Obviously you can insert whether it this side or this side, not at all problem. So you can get, this is a 4-membered ring. So you can get 5-membered ring ketones. This is for what? Our product, right? And most important, if you see the one more examples to you. So here we have a one 5-membered ring. So this 5-membered ring containing one alkyl group. So when you are treating with MCPBA, here I am going to use as a solvent media DCM. So where it will going to, whether it is the insertion of oxygen or here we have a alkenes, right? Alkenes are going to converted a epoxide. Which one? Whether you can see this is the most important in this reaction. When you are using MCPBA, so alkenes are going to converted into epoxides. Not here, you should not introduce any oxygen here itself. This is for what? Our product. And if we see the same example while treating with different reagent, here you can see Me3 SiOOSi Me3, it is treated with a BF3 DCM. So in this reagent, in this when they are giving this reagent, you should not form the epoxide. You can introduce the oxygen here itself. This is for what? Our product. Please remember, this is the one type of an reaction. So this is for what? Our product. So in this is the lecture of regarding Baeyer-Villiger oxidation. I hope you understand this reaction, what is that exactly happening in this reaction. So if you are not understood, please let me know in a comment so that I will explain better. Thanks for watching this video. Thank you, friend.